for presentation. Sorry for this. And maybe one very short question. Okay, so we will start with the first presentation. The presentation title is the analysis of national surveys quality using TiAlTaN-Coated tools in mining operations, and the presenter will be André Pedroso. Stage is yours.
Thank you very much. Good afternoon to all. Thank you for being here. Letting me to lecture about this important work, which was an analysis on comparative milling sessions on coated and uncoated tools while milling AMPCO alloys. For those of you that are not so familiar, AMPCO is a commercial name for copper alloys.
Try the button.
Sorry. Try again.
So, a brief overview of the presentation. There will be an introduction and the major challenges of the study, and that's on to the and the research test, which are the objectives of the work. Then a research methodology, where we will address the materials, the tools, and the machine used in the study. Then, followed by the results discussion with the comparison with the literature and how, and so, for the introduction, copper beryllium alloys are very used in injection molding industry. Here we have some of the examples of molds. Typically, because of their high hardness, surface hardness, and high chemical resistance, alloys are for molding inserts. And that allows to shorten the cycle period of the injection. Normally for inserts of the plastic molding, but also for bushings in the molds can be used this type of alloy. And just for curiosity, in the automotive industry as well for the Baltics. The main aims for this study was to assess, identify, and quantify the tool wear of these tools while regarding the surface roughness obtained. While also assessing tool performance evaluation while varying two types of parameters, which was the cutting length and the feed rate of the machine, and maintaining the spindle speed. So for the research methodology, here is the material that we use with the mechanical properties that are known from our supplier. And then the cutting tools that were coated and uncoated as well, they have this shape, and the respective dimensions are there below. And this was the CNC machine, which is very similar to the one that we saw yesterday, and with the power properties there in the third. The cutting parameters, they are separate. They are similar to the coated and the uncoated tools. For each tool reference, there were 3 tools used, and then we managed to conduct a statistical analysis to perform the median value for the surface roughness. Here are the cutting parameters for the coated tools, but as you can see, there are similar. So, starting with the results, the surface roughness was measured in the longitudinal and the transversal directions. Here in this case, we have the influence of the cutting length in the surface roughness. RA, or the arithmetic deviation, was the main parameter measured to compare the different tools. And as we may see, as long as we are increasing the cutting length and the feed rate as well, we may see that the roughness tends to get higher, in this case for the transverse direction, and the longitudinal direction, it tends to exponentiate for the coated tools because of the abrasion, or better saying, because of the three-body abrasion phenomenon. Just one little detail that coated tools perform better with a more marked setup, which was with the lowest cutting length and the lowest feed rate. Here we have now the feed rate influence in the surface roughness measurement, and what we can see, it's not now in a linear trend getting the evolution, but it has a serrated trend. It's like if we could have a 3D graph, but we sectionate it in the 2D part as we are seeing on the other side, then the other graph would be seen this way. And then we would have a surface as our colleague presented with the influence of different parameters. Here we have the full analysis according to the different setups, and as we may see, the uncoated tools perform better than the coated tools for each setup that we conducted. We have six setups. It was a 3x3 so. One of the main reasons are going to be shown by the same analysis that we conducted. We will start from the lowest of the cutting tools, the cutting length, and the lowest of feed rates to the more abrasive and harsh setup. Mainly in the coated tools that are on your left, abrasion, adhesion, and microchipping were the main phenomena of tool wear seen. While for the coated tools, the lamination of the coating was as well seen, mostly due to the LC2 adhesion force, which was below the 50 Newton. So passing on to the 750 feet rate and the cutting length of 53 meters, we can see that the coated tools present an even more harsh tool wear phenomenon, while the uncoated tools only show abrasion and adhesion from this material. This is the 74 meters of cutting length, but still with the 750 millimeters per meter of feed rate. Now passing on to the 150 millimeters per minute of feed rate, we can see that the chipping of the uncoated tools is getting more harsher, and the coated tools practically lose their coating, and it was even more so. And this is the harsher setup that we use in our setup. So as for a discussion, this is a very brief one. We have our colleague that tested coated tools with the diamond-like coating, and as we may see, the tools with a coating performed even worse than the coated tools back then. And making a comparison of the different coatings, we can assure that the uncoated tools have better results every time. So as for the conclusions, what can we say? The lowest surface roughness were found in the more mild setups. Otherwise, the highest surface roughness were obtained with a more harsh setup. The best peak values of the surface roughness were with the minimum setups, and as well the two were as the same trend of the surface roughness. I would like to thank to CZECH, INEGI, and FEUP for their institutional support, and for the Dr. Bosch which was the professor who conducted the same analysis in Plzen. And we have for the novel tools which provided the thank you very much.
We can move our discussion to the 8 minutes. So 1 minute more. Thank you very much again. Invite the second speaker, we have Raul, right? And the title of the presentation will be Empirical Database Failure Assessment Methodology for the Metals Data.
Mykhaylo, I'm from Zaporizhia National Polytechnic National University. I'm the head of the Department of Metal Cutting Machines and Tools, and also associate professor of this department. And my sphere of interest is a statistic and scientific research, quality management, and statistic and quality management also. So here are the theme of my report. Excuse me. The result of this study can be extended to a wider range of technical objects, which are subject to wear and aging, to analyze their reliability. At the time of preparation of this material, the methodology was tested on metal cutting tools. So the name of this report. But currently, a large number of cases from metal creep distribution to bearing failure distribution, including various cutting tools, have been analyzed. The selection of distribution law describing the failure of particular engineering objects is not a pure approximation task. It must correspond to the physical nature of the cause of failure, and the main difficulties arise when the obtained statistical data can be described by several distribution laws based only on formal Pearson or Kolmogorov-Smirnov goodness of fit criteria. The fundamental difference between these distributions lies in the nature of failure rate, which describe all stages of object life. The failure rate also defined the distribution law by itself. And we see that distribution laws can be very similar, but the nature of failure rate is absolutely different. So there are two problems in determining failure rate based on empirical data. Both of them are related to the fact that theoretical function is continuous, while empirical data are presented in the form of intervals, as you see. Problem one, availability of two approaches for calculation of the failure rate. According to the first one, the number of objects, so to say, alive on the beginning of interval is taken into account. And according to the second approach, the mean number of items alive at the interval is taken into account. And the difference between two approaches reaches 2 times. So there's the problem how to calculate it if the difference in 2 times. The next problem, theoretical failure rate refers to the specific time. Here we have histogram, empirical data, and theoretical distribution law. So the theoretical distribution failure rate refers to the certain time. But as we talk about empirical distribution, so we have intervals, and the question arises which exact time from this interval we should take to compare it with the theoretical failure rate. The research of AIM I will not be reading. You can read it by yourself and to compare, to find the criteria, to compare to these two approaches and to find which one is right. So research methodology is based on simulation experiments and also on a real life experiment from the metal cutting tools on the period of creation of this work. As any random value, failure rate also is a random value. It has its confidence limits. Here we have failure rate and its confidence limits, and there is a value lambda which is connected with failure rate, and it is known that it has chi-square distribution. Basing on this here, upper limit of the confidence limit and the lower limit of the confidence limit, basing on this fact, we found criteria based on the maximum likelihood approach to avoid multiplication of the functions. It is substituted by the sum of logarithm, and here we have opposite negative value to minimize instead of maximize function. Because why minimize? Because it's so they say usually use minimization in optimization theory. So basing on this fact and on distribution of failure rate, we found criteria, condition of maximum probability of predicted values, and found the number of freedom. We can see three approaches for comparison of this criterion. First of one we called BB, so it's both the number of serviceable items and theoretical value of failure rate are taken for the start of time of the interval. BM, the number of serviceable items is taken for the beginning of the interval, while the theoretical value of failure rate is for the time of the middle of the interval. And then both the number of serviceable items and theoretical value of failure rate is taken for the time of the middle of the interval. And based on this criterion, on the basis of the simulation experiments, we found that this approach is the best because the value of this criterion is the minimum. The next we compared the number of samples and found sufficient difference when we comparing these approaches. And another, so to speak, third-party effect of the development criteria is the possibility to choose the distribution law based on the nature of the time dependency of failure rate, which reflect the physical nature of the process. Here we have results of comparison of different distribution laws. It's a variable distribution, gamma distribution, and normal distribution. In comparison with the empirical histogram, you see these all three distributions are very close to one another, but based on this criteria, and all these laws, the significant difference in failure rate, excuse me, it's all used to all three distribution laws. But we see that absolutely different nature in failure rate character inside the confidence limits. So based on the development criterion, we found that the minimum value of this criterion is for normal distribution. So based on this, we can choose the normal distribution for this process. Here, conclusion, please. presenting. And also conclusions, and of course, acknowledgement. Thanks for everybody for yeah.
And let's invite the last speaker, Professor Butdee from my university from Thailand, and the title is ANFIS system for stress prediction of competing fastener body processes for a steel-based composite.
For joining to accommodate together, based on several materials based on the case performed by watching cases to mix and can improve the property of materials. The environment made of composite, alloy, stainless, and other materials, but they use only single material. One of the motivation is why don't we use the new materials for the lighting for the yeah, the lighting of the materials is innovative way to investigate the new material for the future. How that so we can combine material also the property of the product we use. Now let me show you about the previous study at the University they did the composite code for the this is our study. We study a lot of the code watching, and we study what we are inside the die of the watching. And this is the single material and this by material together with the base and for material, and then the forms will be mixed. This is another one explanation for our team of study. Due to PD, we don't know exactly what's going on inside the die, and we cannot see what happens in the quality of this part. We use the initial factor and violation of the AMPCO system. And this is another one we have asked for the prediction of the quality of the components. We have integrated factor, and also we do the rating for the that we can see the result. And also we can compare the rules. The result of the model is the simulation we use before, and it is successful. And we can play the surface simulation for the and also we need to calculate so that's why we believe that before and the model is going together. And this is our model. We select three input variability function. Heading ratio is very important. State of the line also state of water. And we make the PD state, the state of the P4 is limited to the state of the button, so that's why they have the PD channel state, and also the state can it's comparatively to the default. So this is the design for our structure to be things and this is the balance we use on the low steady later we use 1, 3, and 1.5. Stay on the beginning. 250 until 750, and then we use 3 stage 5 and 7. And the state we need start from 20 to 5 14. So this is all from the this of the model. So we can be related to the state of state, and also the state is the variation related to the state. We made more state and then we pay more going and if the result of the model, then we can see this. And we test our plan and rules which before very we can see that and also the design is going together. So it's like from this law for the next step we are going to reality and then we will link to the so this is the what we do for this what we call is metal composite material using the steel and aluminum to do the element into the spot. So for the function, our paper presents and resistance for the stability of the offsetting whole body to make a keyboard of the partner using composite method. Metal based and aluminum core. The state can convert to maximum state of the partner under maximum working load. State is observed by compression force being parameter and converted by positive integration, which is required by customer. State of the material based on the design specification, stated of the pumps and design. Quality rules are created and stored in the quality operating system. Such rules are captured from experts in the factory shop floor and also the technical data from the maker of the tool. This is a contribution of our work. That the state of the composite metal base and aluminum core, which is done before in the application. So we are going to contribute about the lightweight material for the composite in this area. Thank you very much. Thank you.
Thank you very much again. Thank you all present. And enjoy the trip, right? Next trip, and you are there. Thank you very much for being here. It's a pleasure. So I think that
Remember that the conference has ideas and change, and also we are starting now so we can interact not only on social issues but also scientific issues. So I invite you to take your materials and we go to the class. Thank you very much for today's program. Agenda is scientific agenda is completed. Let's go to the next stage. Thank you very much.